let's continue walking through the non-AP Calculus spring review worksheet. This is number 6. Find the equation of the tangent line. So tangent line is going to take on the form of y minus y1 equals m times x minus x of 1. So we need to find our slope. To find our slope, we have to find our derivative. To find our derivative, we're going to apply the chain rule here. So the rule for e to the u is e to the u times u prime. That's our derivative. That's our slope formula. We can bring that negative 5 and the 2 together to make it negative 10 e to the 3 minus 5x. We have our slope formula. We just need to plug in our value, our x equals 1, into the derivative. That will give us our slope. If we plug 1 in, we get negative 10 times e to the 3 minus 5. That becomes e to the negative 2. We can push that e squared down to the denominator. So that's our slope. This doesn't seem like a number, but e is around 2.72. So 10 over 2-ish, 3 squared is going to be a little bit over around negative 1, negative 2. So that is a number, it's just written as an exact value. So we have our slope, we have our order pair that's given to us at the beginning of the problem. So now we just put into point slope form, y minus y sub 1 is equal to m times x minus x sub 1. Okay, number 7, we are now moving into antiderivatives. So one of the first rules that we can try to apply is, can we rely on just expansion power rule? So we can bring that x squared up to the top, make it x to the negative 2. Let's close off our numerator terms with a set of parentheses. And then we can distribute through. After, I can do a little bit of cleanup here, or rewriting that square root of x as x to the 1/2. So now we can expand or distribute by adding exponents. So 3 minus 2 is 1. 2 minus 2 is 0, so this gets us down to 3. And then 1/2 minus 2 is negative 3/2. So now we apply power rule. 2x becomes 2x squared over 2. 3 becomes 3x. X to the negative 3/2 becomes x to the negative 1/2 over negative 1/2. Cancel, clean up, force that negative 1/2 to come up as negative 2. Bring the x to the negative 1/2 back down to the denominator. And we have our, and then plus c to indicate our indefinite integral. Okay, number 8. We have two rules that can handle this 3 to the 5x and the cotangent of 2x. This matches the form of a to the u du, which is 1 over natural log of a times a to the u plus c. Cotangent of u becomes natural log of sine u plus c. So we really are just treating these like two separate u substitution problems that we're going to put into their appropriate rules. So in this case, our exponent is our u value for the first term. So we let u equals to 5x. The derivative is just 5. Cross multiply, we get dx equals du over 5. Once we have our u value and our dx identified, we can start making our substitutions. So the 5x gets replaced with u. The dx gets replaced with du over 5. There's no more x's, so we know we're in a good spot to move forward. We just want to do a little bit of cleanup here. I can make that 5 in the denominator come out in front as 1/5, and now I can make what's between my integral and my du sign, make it match my the rule that I want to follow. So the rule says, once I have a to the u set up and ready to go, I do 1 over natural log of a times a to the u plus c. So 1 over ln of a, so that's 1 over natural log of 3. The 1/5 is in front just to hang out with the, attaching to our answer. So 1 over natural log of a, in this case natural log of 3, times a to the u, in this case times 3 to the u. Okay, and then we can clean this up, make it, bring this u back in terms of x, and make it 3 to the 5x. All right, so that's the first term. The second term, we also are going to find the antiderivative. It has a different u value, so we have to go through a separate step for its u substitution. We let the u value be 2x. and we want to find a way to substitute this dx here. So our u value is 2x, derivative is 2, cross multiply, we get dx equals du over 2. So I can insert u in for the 2x, and then plug in du over 2 for the dx. Notice their x's not goes away nicely. We can push that 1/2 in front, and we have 1/2 not cotangent, integral cotangent of u du, and that matches with the rule that we want to use, which is natural log absolute value of sine of u. So we keep the negative 1/2 as a coefficient in front, natural log sine of u plus c, and then replace the u back in terms of our original u value for the cotangent, which is 2x. So we solve the two separate problems differently at separate times, but then we're going to merge them back together, have that represent our indefinite integral. All right, number 9. We're going to rewrite this problem. Denominator, rewrite it as parentheses to the 4/5. We bring that parentheses back up to the top. We're going to have to go through u substitution. We let the u value be what's inside the parentheses. And we're hoping that when we solve for dx, we're going to be able to find a way to get rid of that x squared that's sticking out, preventing u substitution. But hopefully we can get those to cancel out. We let the u value be e minus 2x cubed. The derivative for e is just 0. That's not a variable. It doesn't go to 1. It goes to 0. Treat e like you would 2 or 3 or 5. It goes to 0. The negative 2x cubed becomes negative 6x squared. Cross multiply, we get dx equals du over negative 6x squared. We make our substitutions. This set of parentheses gets replaced with the u. The dx gets replaced with du over negative 6x squared. We get the x squared to match and cancel out nicely. We can push the 5 and negative 6 out in front. And now we can see clearly this is a power rule problem. We add 1 to the exponent. So plus 5 over 5, which becomes 1/5. We copy that exponent value below, and then plus c. The negative 5/6 hangs out, and then we can clean this up a little bit. The denominator, push that out as 5 over 1. So that gives us negative 5/6 times 5, which is negative 25 over 6. And then finally replace our u back in terms of our original parentheses, which is the e minus 2x cubed to the 1/5, and then the plus c. All right, number 10. This is a washer method problem, volume problem. Diagram shows the shaded region bounded by y equals negative x squared plus 5x plus 1. That's the parabola that we see opening down. And y equals x minus 4. That's this linear graph with a slope of 1. Find the volume of the solid created by revolving the shaded region about the axis of revolution. So we're revolving this shaded region around the line y equals 8. So y equals 8 is this line that's here. We see there's an obvious gap between this shaded darkened region and the axis of revolution. So we're going to have to go through a washer method. Now there's going to be a gap or hole that we have to account for and make sure we subtract out. But we also need to find the intersection so we know our bounds at the furthest left of our shaded region and the furthest right of our shaded region. So to do that, we're going to set the two equations equal to each other, the x minus 4 and the negative x squared plus 5x plus 1. We'll go ahead and add and subtract so that we can bring everything over to one side, get 0 to show up on the other side so that we can factor. When we factor, we get x minus 5, x plus 1. Solve for x, we get 5 and negative 1. So our bounds are going to be from negative 1 to 5. Okay, so we have that taken care of. The next thing is we have to find our two radius that we need, since we're going to be subtracting these radius that form circular discs that we're going to subtract from one another. So the big radius is going to extend from the dotted line, from the axis of revolution, all the way down to the furthest boundary of our shaded region, which in this case is the x minus 4, the linear graph. And that's big radius. Big radius is always going to be a one that's longer. And the shorter one, that's the hole that we are subtracting out, is this line minus this parentheses, this parabola, this graph, this curve. So we have 8 minus, so top minus bottom. For big radius is 8 minus parentheses x minus 4, which cleans up to be just 12 minus x. And in little r is top minus bottom, so the top is sitting at the 8, and the bottom of the radius is sitting on the curve. So 8 minus parentheses negative x squared plus 5x plus 1. Combine like terms, we get x squared minus 5x plus 7. So we have pi definite integral from our left to right bound from -1 to 5, big radius squared minus little radius squared, and we use our calculator to evaluate the volume, which comes out to be 460.8 pi, or 2304 over 5 pi cubic units.